Hello and welcome. We look at the cathode ray oscilloscope. We require a signal generator which feeds with the frequency, which is adjustable. The frequency multiplier knob is there, and then the amplitude and where we set the voltage. Then the two knobs are where we put the input of the signal. We can also have the output as the speaker. So we put the signal generator on, and it shows the symbol for AC in use. So then we can get to our CRO. We put it on. Then we have the two knobs on the left. One controls the intensity of the signal, and the other one is to focus. Then we can adjust according to whether we need the input both on the X and the Y displayed, and set the input at the center using that knob. So then we can adjust the time base on how we require the input frequency to be using that knob. So getting back to the CRO, or we can get the output using the negative and the positive from the signal generator, using the two cables which are going to connect onto our oscilloscope and feed it with an input, so that we can see a display on the screen. So we connect to that, and then we expect to see a change. So we have to choose the frequency we are using. We have two sections, channel 1 and channel 2. We can opt to use channel 2 and then stick to the knobs for the channel 2, that is on the right hand side of the CRO, or on the left, either way. So when you've done the connection, there is a display on the CRO of the wave of the input from the signal generator. Depending on the voltage adjusted, we can increase the amplitude of the wave. We can also increase the frequency, and that will be observed on. So at this moment I'm adjusting the amplitude, so reducing it and then increasing it, so you can see the display on the screen. Then when increasing the voltage, you can see what happens. When I increase the frequency, again there's a change on the screen, and when I increase furthermore using the multiplier, the frequency increases even more. So those buttons or knobs on the signal generator are meant to adjust the frequency being fed onto the CRO. Then we can increase the focus or the intensity and the focus using the knobs. Then we can increase the time base, so serving the same purpose as increasing the frequency from the signal generator. So a CRO perform various functions, and it's an instrument or an electronic instrument used to obtain waveforms when the different input signals are given. And as you can see, once we increase the frequency, the display on the screen changes. So it is divided into several sections: the display section, the controllers and the horizontal controllers, and of course the triggers. So when you increase the frequency, the display on the screen increases as well. So meaning the input has a very high frequency. When you reduce the observation made is as well noted. A signal generator can also be used to test even the pulse from a person's heartbeat. So the pulse will act as the input and we can see what happens on the screen. Now what is CRO? So CRO is a development of the cathode ray tube, and a cathode ray tube is as a result when a metal is heated at a very high temperature, electrons are emitted from its surface. And this is because electrons gain enough energy to enable them to break loose from the force of attraction of the nuclei. And this process of electrons emission due to heat energy is the ones we refer to as the thermionic emission. And from the thermionic emission, that is where we get the cathode rays. And the cathode rays are streams of electrons moving from a cathode to an anode, and they are produced in a cathode ray tube or a CLT. And electrons are produced through this process we are calling thermionic emission, and are accelerated toward the fluorescent screen by the anode, which is connected to a positive terminal or an extra high tension. The tube is evacuated to prevent electrons from interacting with any particles before reaching the screen. And it is through these that cathode rays are obtained, and a cathode ray oscilloscope is therefore the development of the cathode ray tube. Is therefore a development of the cathode ray tube. So basically that is how electrons are, or the display is on the screen as seen. When you vary the frequency, you increase the amplitude, you increase the time base, those are the results we expect, and these wires are the ones that brings about the input. And like I said earlier, we can check the pulse, or we can feed the pulse from a human body. So these are my hands, and these are now acting as the input, and that is the result on the screen. You can see the frequency, it's very, very high. That's therefore my heartbeat. Thank you for watching.